Hello and welcome back to my channel. I am Echo Tree, and today we're going to be taking another look at additive manufacturing. This is episode 2 in my series Introduction to Additive Manufacturing, and today we're going to be taking a brief look at the anatomy of a 3D printer. This is going to be more of an overview. We're not going to be getting into the specifics. I realized my last video was like 40 minutes long, and that is just way too long. So we're going to start with how do FDM printers work. Again, they get hot, they push the plastic into that hot melt zone, they melt the plastic, they push that plastic onto either a surface or pre-deposited material, they move, and then they repeat the process. To start everything off, we're going to look at the skeleton of a 3D printer. The frame. You have a bunch of different styles of frame, and we'll get into them a little bit, and then a little bit more when we talk about the motion system, but we'll cover these in more detail in a later video. You have different styles. You have Mendel / i3. Those are very similar, and I'll show you the differences in a minute. Core XY is also a little bit different. HBots aren't as common anymore, and then you have deltas, and I'll show you these guys kind of at the end. The most common things they have between all of them, the core components of the frame are usually made up of metal. Older printers and some like Voron, they use extruded aluminum. That is just aluminum that's made into a shape, and then it's really easy to just connect together. The Sovol here, this is actually an i3 style machine. But we'll look at the frame really quick. You have two struts that lead up. We call these the Z profile. You have a cross member here that stuff's attached to, and then you have the Y profile down here. This is a Mendel style 3D printer. The biggest thing you'll notice here is that the frame is actually this weird triangle shape where you have this all thread style screw that connects these plastic pieces. The i3 style made this kind of A-frame more common, where you have solid extruded aluminum, and then you have the motion system that's attached to the aluminum itself versus kind of separate and riding on these rods, as you see here. This is a Bambu Lab. This is a Core XY printer. I couldn't really get a decent picture of the frame for this guy. I have a K1 that uses the same style of motion, but it's currently in use, and I couldn't get a good picture of the frame there either. These guys, they have like a like custom made aluminum frame. It's like stamped or cast pieces that are really easy to connect in a square manner. On the frame itself, you'll want to make sure that it is perfectly square. You don't want it to be slightly angled, because it'll put that angle into your pieces and it might make them harder to come out, or it just runs into the pieces. And you also want to make sure it's sufficiently tightened. You don't want any looseness causing any issues with your prints either. So next up is the electronics compartment. This one's pretty easy. I don't really have a good name for this guy, the electronic housing, cluster, whatever you want to call it. This is usually where the brains of your printer live. You have your main board, usually the controllers, all the stuff, and then all the wires go in and out of that to actually control everything. Don't touch it while it's in use. You don't want to short anything. Next up is the power supply. That's this big old thing right here. Usually it's what you plug in from the wall. This guy has a bunch of electronic components in it, including transformers, capacitors, things that store and change electricity from one form to another. I highly recommend not messing with this guy, even if you know what you're doing, unless you absolutely know you have to. There's a lot of dangerous stuff in here. It takes the 120 or 230 volts from the wall, steps it down to that 12 or 24 volts that your printer uses. It can be pretty dangerous. Next up, we have the tool head, also commonly called the print head, the extruder, or the hot end. You'll see these terms used interchangeably, especially now that they're all kind of on the same area. Some older printers will have this extrusion mechanism relocated to somewhere else, and it pushes filament through a tube into the hot end. So this is kind of where definitions might matter a little bit. If the extruder is not part of this piece, we don't want to call it the extruder. We'll want to call this piece just the tool head, and then the extruder is wherever the extruder is. Usually it also has the part cooling fans, not just the heaters. And then sometimes it'll also have its own little board with its own controller attached with like accelerometer and other sensors and stuff like that. We'll get more into this later. We'll have a full dissection, stuff like that. But for now, tool head, print head, all that good stuff. Then we have the bed, and I put heated in parentheses up here because older printers actually didn't have beds that could heat up, and so that at one point that was an important distinction to make, whether it was a heated bed or not. This thing can usually achieve 110 degrees Celsius up to 230 degrees Fahrenheit, and I actually forgot, most modern tool heads, those actually get pretty hot too, up to 300 degrees Celsius or 572 degrees Fahrenheit. So no touchy this thingy, and then no touchy this if it's really hot. Though 60 degrees Celsius is only 140 degrees Fahrenheit. That's like hot coffee hot. This guy does need to be kept clean of debris and contaminants. You don't want to be printing over stuff and messing up your prints, and if it's dirty or there's like oil on it, the prints can just pop right off mid-print, and you don't want that. All right, next we have the motion systems. Uh, First off, there's a ton of different types of motion systems, but most modern like consumer grade FDM printers use some form of Cartesian coordinate system. And so you have your standard ones like your i3s here, but also things like Core XY and Delta printers. And so all of these guys use different subsets of the Cartesian system for their motion system. Usually you will see people refer to like this i3 style as a Cartesian printer, and then a Core XY as like a Core XY. Those are more differentiating between the types of motion systems used, not as much the actual coordinate system used. Like I said, they all use the Cartesian motion system. With that said, there's a little bit of information to go over here. We'll start with the actual motion system. 9 times out of 10, it's got a motor on it. Unless you're doing some weird stuff, you're going to need a motor to drive that system. There are some magnetic inductive ones out there, but we're not going to get into that today. You also have gears, belts, and carriages. Carriages are like these little guys right here on the actual system here. It has some sort of uh, like bushing or wheel or something to allow it to move evenly across that axis. And then it's motivated by a motor, and in this case it's the z-axis, so it's a screw. But over here you have a motor and then belts that move this carriage that carries the tool head across the x-axis. Sometimes part of the frame moves. In this case, if we look at this whole thing here, you have the two rods that connect to these two plastic pieces that make up part of the frame for the x-axis here. It moves up and down across the z-axis but because it holds the parts of the x-axis that move, we'll call it the x gantry. Other printers similarly have it move on the x or the z-axis. Some printers have it move forward and backwards across the y-axis, but because because it holds the moving parts of the x-axis, we'll call it the x gantry. Um, like I said, tons of different styles of motion. The Sova that we're looking at and these guys, these are called bed slingers. They're standard Cartesian. They use a standard rectilinear motion system. You have the Core XYs. These guys are a little bit different. Instead of it being one motor per axis, one motor here, and then one motor on the Z, or sometimes two for stability, but they receive the same signal, so it's still treated as one motor. This guy actually has one motor on the z-axis and then has two motors that connect the tool head to the x and y, and they work in tandem, and so that's why we call it a Core XY. It's a different set of calculations. Like I said, it's still part of the Cartesian system though. And then lastly, we have the uh, Delta printers. And these guys have kind of a different style of handling the motion as well. So if we take a look at one, you have this weird setup, triangle base, 3Z profiles, and look at that, it's oops, all Z axes. And so you have 1, 2, 3 Z axes here, and the printer uses the difference in the positions of each axis to determine where the tool head currently is, and then does a bunch of calculations to figure out which axis to move up and down to move it to the next spot. So this guy still uses the standard Cartesian coordinate system though. It's just a different style of motion. We'll get into kind of the bed slinger style, the rectilinear, and then the Core XY later on. Unfortunately, I don't have a Delta. I would love to go into a dive on these guys, but yeah, so that's going to about do it for us today. If you have any other questions, comments, anything like that, please leave them down below in the comments section. If you liked the video, if you liked the information presented, please leave a like. Otherwise, thank you so much for watching and have a great day.